Okay, I'm going to do a review. I already did the video and did the review and the sound was terrible. I'll leave that video up. If you want to watch it, just search for it on my YouTube channel. So I'm just going to go through this kind of quickly. This is a review for sections 9.1 through 9.4 on quadratics and the basics of quadratics. So examples of quadratic functions. If you're asked to give a graph example or you're looking at graph examples, it's going to be a parabola. And that is either a facing up or opening up parabola or the opening down parabola. It cannot be a sideways facing parabola. That's not a function. It doesn't pass the vertical line test. If you're asked about an equation for a parabola, it's going to be y equals or f of x equals in function form, and you have to have an x squared term. So an example would be x squared plus 4x plus 3. You must have a second degree term, no less, no greater. That makes it a different kind of function. This right here, remember f of x equals x squared is our parent function. We compare everything to this basic parabola. If you're given a table of values, you first have to check the x difference, whether it's constant or not. That's your first thing. The second thing is the second difference of your y values. So go through your y values, find your first difference. Hopefully it's not the same. If it is, it's linear. And then check the second difference, so the difference of the differences. And if that's constant, then you have a quadratic. If all else fails, I have a special note here. When in doubt, create a table of values, or if you have a table of values, graph it. A graph will always tell you. Okay, so going on to graphing, I kind of apologize. This is all filled in and it wasn't filled in before. So there's 6 steps. The first 4 we work out, and step 5 and 6 go actually on the graph. So step 1 is to find your axis of symmetry. Remember our equation, the opposite of b over 2a. So here's my quadratic that I'm trying to graph. Y equals x squared minus 4x. So my a value is 1, my b value is negative 4, my c value is 0. So the axis of symmetry, I worked it out over here, the opposite of negative 4, my b value, 2 times 1. So what did I end up with? 2 negatives make a positive. 4 divided by 2 is 2. Let's write that in there. I didn't write that before. I just came over then and graphed. So I went ahead and put my axis of symmetry on my graph. Second step is to find my vertex. I take my x value, so I take this x value of my axis of symmetry 2 and I plug it in to my equation. So here I plug it in, 2 squared minus 4 times 2. So 2 squared is 4 minus 4 times 2 is 8. So 4 minus 8 is negative 4. So this kind of goes up on this step. So my vertex is at 2, negative 4. So I went ahead and plotted that over here. Step 5 is actually plotting all your points, but remember in previous videos I said I plot points as I go. Step 3 is your y-intercept. Remember your y-intercept equals your c value. And in this case, my c value was 0. So my y-intercept is 0. So there was that point. Fourth step, find 2 points on the same side of your vertex as your y-intercept. Well, what I did was I said, you know what, these 2 points are pretty far apart. I kind of have a general shape. I'm just going to choose one more point. The point that I chose was on the same side as my y-intercept. I chose negative 1. So here's negative 1. I plug it into my equation, negative 1 squared. Remember, anytime you have a negative, it always goes in parentheses. Minus 4 times negative 1, so 2 negatives make a positive. Negative 1 squared is 1. 1 plus 4 equals 5. So I got the second point, negative 1, 5. So negative 1 up 5. So those are the points that I graphed. Step 5 is to plot those points. Step 6 is to mirror the image and draw in the shape. So this y-intercept is 2 points to the left of my axis of symmetry. I'm going to go 2 to the right of my axis of symmetry and right along the x-axis draw in that other point. Negative 1, 5 is 3 places to the left of my axis of symmetry. So I'm going to go 3 places to the right of my axis of symmetry, and along that x value or y value of 5, draw in that point. And then it's just a matter of drawing in your parabola. The zeros of a function is where it crosses your x-axis. So if I go back to this function that I just graphed, my zeros where this parabola crosses the x-axis are at 0 and at 4. How do I know those are zeros? Plug them into the equation. So if I plug in 0 into this equation, let's just pull it down, of x squared minus 4x. 0 squared minus 4 times 0 equals 0. It really is a 0. 4 squared minus 4 times 4, 16 minus 16 equals 0. It really is a 0. Where will I ever use these zeros of a function where it crosses the x-axis, especially in real life? Anytime something makes a curve in real life, it's related to quadratics, and we can tell a lot of things about that curve and the applications for it. So let's say you were doing the egg toss in physics, and you tossed your egg off of the school and it hit the ground. Okay, well here's my height versus time. So here I started at the height of the school, dropped it off, it hits the ground, boom. Okay, so that's my x-axis right there. Where it crosses or hits that x-axis, that's how long the time in seconds that it was in the air. Now keep in mind, if I check, let's say I check 1 second, and I get an answer of 0, then I go, well, it wasn't even in the air. Oh, it was only in the air for 1 second. So you've already found one of your zeros. Okay, and the last thing I want to quickly discuss is what do the a, b, and c values represent on a graph? How does that change your graph? So remember, I've got plus or minus ax squared plus bx plus c. Okay, so I'm sorry I've already broke this down. I'm just going to go through it quickly. Plus a means it opens down up. Minus a means it opens down. Also, a values, the larger a means a narrower parabola. A smaller a, remember, like a fraction, makes it grow very slowly. It opens it up really wide and you get a big parabola. A large value of absolute value of a makes it grow very quickly and I get a really narrow, skinny parabola. The c value is the next thing we kind of discussed. It was the y-intercept. Okay, if you're asked to find the y-intercept, it's just your c value. And so that shifts it up or down along your y-axis. The one thing we didn't talk in detail about was your b value. That shifts your axis of symmetry sideways. How do I know that? Well, if I come back up here, my axis of symmetry deals with that b value. And the last lab that we did in 9.4, all of those functions had no b value, and it stayed on my y-axis, and it just shifted my graph up and down. So that b value shifts it sideways. Okay, and those are the main points of the first 4 sections of Chapter 9. Good luck on your quiz.